Okay, so let's start the class. So this is our day 1 class for GATE Aerospace 2025 and today is 15th Feb of 2024 and I will discuss about syllabus and then I will discuss about very important points about the preparation as this is day 1. So then I will discuss about deadline of the course and then I will also say that we have revision plan and we have crash course batch as well and then test series importance, everything. So I'm changing the page. So first of all, I'll discuss the very important points regarding this live batch. So you know that very first point about a live regular batch is you are going to be regular. Many of us are really regular in video courses as well, but most of the public is not regular in video course batch. So what they do in the last moment, they don't, I mean in the last moment they used to cover the syllabus because videos will be there, assignments, test series, everything will be there. So in the last moment they will prepare and in the last moment they will be asking all the doubts. In the last moment they will feel pressure. So if you are coming to the live class, like many of you have come to the live class today, we have anyway we have only 15 students at day 1. So I welcome all of you in this live class. So see here, because you guys are coming to the live class, it is really good for you because with me you are going to finish the syllabus. If you are not finishing the syllabus with me, then already you are in danger zone. So important point is you have to finish syllabus on time. So finishing syllabus is one thing. After that you should have enough practice. If you have finished syllabus, if you have done enough practice, it means you are ready for GATE exam. But when you say finishing syllabus, what do I mean by finishing syllabus? Finishing syllabus means you have to come to the class every day and you have to ask your doubts when you are solving assignments and test series. So what is going to be your pattern? See, when I am teaching you any topic, just based on that topic. And one more thing, very important thing, this is a 40 minutes Zoom meeting. After 40 minutes, because I don't use premium version of Zoom, so after 40 minutes we'll be having 10 minutes gap. In this 10 minutes gap I have scheduled questions for you. So immediately when this Zoom meeting will get over, whatever point I am teaching, immediately after 10 minutes, after 40 minutes, this Zoom meeting will get over. So in this 10 minutes, what will you do? I have question on Google Drive. Okay. Already I have prepared today's question. You will go there and 10-minute question you will solve. Okay. Today I have scheduled 3 questions. So within 10 minutes, you have to solve these 3 questions. And when I will log in again, so within 1 or 2 minutes, everyone will join again. Okay. So it means what? In this, when you will come back, that time is not being waste. You are solving some numerical. So I was saying when I will finish any topic, then how will I say that you have finished your topic? So based on the topic, I have given you assignment. So you have to finish all the assignment and then you have to solve topic wise test series. Okay. So for that you have to go to my portal conceptlibrary.in. Okay. When you will go to the portal conceptlibrary.in, there you have several exams, but you have to open the folder GATE Aerospace. Okay. When you will open GATE Aerospace folder, there you have topic wise, chapter wise, subject wise, and full length, all the test series active at a time. Right now it's active. So if you have paid the fees, if you have taken the admission, it means it will be visible for you. If you have not paid the fees, if you have not taken admission, but whoever is coming here in the live class, I can see 18 people, 18 students added today. Very good. So for you, this will be visible. Test series will be visible, right? So then topic over and assignments based on that topic over, it means, and one more thing, in class also you will ask doubt, and when you are solving assignment, that time also solution is given. Read the question, try by yourself. If you are not able to understand, see the solution. And if solution is also not visible, then if you're not able to understand solution, ask me your doubts. Okay. So when you're asking doubts, it means I will understand that you are ready. After that, topic over from my side, topic over from your side. Then you will go for topic wise test series. How? You will go to the conceptlibrary.in website and there you will go to the folder, like I said, navigate that and you'll be getting the test series. Open topic wise test series. It is exactly like a GATE exam. You'll be having a screen, you'll be having photo icon here. You'll be having all the bubbles here, 1 2 3 4 5 6 7 8, all the numbers here, and you'll be having question written here exactly, and you'll be having calculator. And see, for 1 year you should use this GATE calculator at least once in a day. Like as per my plan, we have 5 days class, right? So in 5 days class, immediately after class, you should solve or you should touch GATE calculator. You can do one more thing. You can download GATE calculator in your phone also or in your system also. So that GATE calculator you have to use every day, so that all the buttons should come in your memory and you should know all the operations. You know, this year before GATE exam, before 4-5 days of GATE exam, one student was asking, sir, if I have to calculate log, I will use ln or log in the calculator. What kind of question was that? Anyway, it does not matter, because in the last moment many students used to join and they don't do enough practice. So you understand that how to cover the topic done. In same way, 1 topic, 2 topic, 3 topic, 4 topic syllabus will get over on time. Now what will be my limit for the syllabus? So see here. So importance is fine. You know the importance. That's why you are preparing for GATE exam. Now deadline will be October first week will be my deadline to finish the syllabus. If you are preparing for 2025, October first week will be deadline from my side, and many of you will not be able to finish in time if you are not serious. See, one more thing. You have 1 year. So follow all my routines, follow all my words for 1 year. You need proper guidance for 1 year. I will be giving you. But if you will start ignoring me, if you will start ignoring my words, like I'm sending you text, after 2 days you are replying. So all those things, if you will do, then nothing. This time also many students will not qualify from my coaching center, and you guys will be one of them next year. Okay. And many students who are following well, they are going to qualify and they are going to get a very good IIT. And one more thing. In class of like in everyday class, I don't discuss anything else other than topics. I mean, I don't crack jokes. I don't like, I take classes very seriously. So my classes for 1 hour will be very seriously classes, right? And I was telling about revision. What do you mean by revision? Revision is not like you have to learn new things again. No. Whatever topic you have done, that topic you should keep in mind almost every day. And if you're forgetting any topic, then you go and revise. Okay. So like I said, you have 3 types of notebooks. One notebook where you will be writing everything, whatever I'm writing on the screen and whatever I'm saying. So this notebook is your master notebook. And you'll be having one more notebook. There you'll be writing only formula. So when I'm teaching you on the screen, when I'm speaking something, then it is not possible to write everything. So, but videos will be available next day. So if you feel that sir said something very important, so next day you can play the video and you can watch. So all the students, whoever is coming to live class, they will be having access for the video. So whenever you want for 1 year, you can access the video. Okay. Now next, you should have one more notebook. In that notebook, you will be having doubts. So you have to write down your doubts. Why writing down doubts is very important? Because these doubts will help you during GATE exam. Before GATE exam, you have to revise these doubts also. Like, still do you have doubt or not? The doubt can be very silly doubt. Now see here, I will discuss about a very important fact. Many good students they're really good, but still they will not perform very good in GATE exam. So I find that there are 2 reasons that student is good but still not performing good in GATE exam. First thing, lack of practice. So your practice is not enough. Okay. And second thing is human error. So if your practice is not enough, then work here and do lot of questions. Everything I will be giving you. See, I have some level. If you cross this level, go to next level. I'll give you again question. Go to next level. I'll give you again question. And what is the beauty of learning with me? I will be there always to solve your doubts, to explain numericals. Wherever you will get stuck, I will solve same day. And you also don't keep your doubt pending. If you are solving a numerical, if you are having doubt, ask me. Then you will be having human error. So human error you can tackle as like, how will you tackle human error? Sudden errors you can't tackle. Like, it is based, like, it is your personality. Okay. And if you think that you can work on your personality, you should work, because anything you can change in with practice. So practice a lot. So for that only I have test series. Okay, currently I think 285 test series something is there. I have forgot because I have prepared can someone tell me, Priyanshu, can you tell me how many test series we have right now on portal?
Yes, sir, around 285.
Yeah, okay. Okay, so some 285 test series are there. So you have to solve all the test series. So see, one more thing. See, right now we are going and we will finish our syllabus October first week. Okay, then after October, November and December, these 2 months are there. So by the end of December month, you have to be completely ready. Completely ready means you have to learn all the fundamentals, you have to learn core, you have to learn aptitude, you have to learn math, and along with that you have to solve assignments, you have to solve test series, and you have to solve very tough questions. Everything you should finish December. Okay, then whole January will be very calm and very good month for you, because in this January nothing to practice, only keep revising formulas. Okay, because everything whatever you are practicing will give you some knowledge. Those knowledge you will be writing down on a master notebook. So whole January you will revise properly. Now some students are sitting here, they have recently taken GATE exam 2024. Now I want them to share their experience in very less time, as less as possible, and I want them to share what was their experience. So in that, first I will say, because they have been my student, so they will say few words about my teaching style, about my coaching, and then they will mention what kind of improvement they are going to do this year, and you guys will follow these old students. Okay, so they are going to say some words. So I will start with, because time is very less, so I will not call everyone. Himanshu, you start and you tell me, are you comfortable with this teaching and coaching everything? And next then you explain what are the improvements you are going to do this year in your preparation. Let's start.
Sir, did you mean Priyanshu?
I'm sorry, Priyanshu.
Like me?
Yes. I'm very sorry. Yeah,
Sir.
Priyanshu.
Sir. Okay. Good evening, everyone. I am Priyanshu Mohanty. So, sir, teaching style of sir is extremely like he explains every concept. So that way, concept wise, I am extremely like every student can grab the concept very easily and in very less time also. So, sir, about teaching concept, that thing is clear. Sir, the next thing. So, what are the?
Yeah, what are the improvements you are going to do this year in your preparation?
Yes. Yeah. So one of the major mistake which I did last year is not to focus on each and every topic based on practice. So that way I realized at the end that we need to focus each and every small topics also, and we should practice more on each and every topic, especially when a student has time, like starting his preparation from very beginning of the year. So that thing I am going to change in my preparation this year.
Okay.
I am going to practice more. Yes.
Okay. Thank you, Priyanshu. Sorry. Now, yes, even Banani is my old student, and actually these students, they have joined me for 2 years. So just now Priyanshu shared his experience, and now I will call Banani to share her experience. So Banani, are you comfortable with teaching and coaching? And next thing, what kind of improvement you are going to have in your preparation this year? I mean, what are the add-ons I will expect from you in your preparation this year? Banani.
Yes, sir. Okay. So one thing I like is the concepts. The way you teach the concept is like really appreciated. It's amazing. And from my point of view, I want to add on the formulas, because I feel if I remember the formulas, it gives that extra confidence. So, and like last year, I was not regular with the formulas. So formulas, I'll mainly focus on formulas. Practicing is also like it comes after that, I feel like. So I'll mainly focus on these things.
Okay, thank you. So now we will start our today's lecture. And before going into the lecture tonight, if anyone, like rest of the members, if anyone wants to ask anything, like Gurleen is there, Aniket, Tej, Bhavani, Keshav, Kumresh, Om, Pradnya, Pranav, Priya, and Sricharan, Tarun, Vaishnavi, Vanshika, all of you, if you have anything to ask, feel free to ask, and then I will start the class. Or if you want to say anything, most welcome. Anyone? Okay, then I will start the class. So this is our day 1 class. So in day 1 class, first of all, I will explain which subject I am taking. So I am taking aircraft propulsion. So let's understand the meaning of aircraft and then propulsion. Aircraft, anything, or you can say man-made objects which can fly in the air. They all are aircraft. So in one way you can say even a bullet is aircraft, bullet coming from the gun. Definitely rocket is also aircraft. There is difference between aircraft and aeroplane. Rocket is not aeroplane, okay, because rocket has to go, rocket is also example of a spacecraft, right? So aircraft means anything which is flying in the air is aircraft. Rocket is also aircraft because rocket has to travel through the air and then it will enter to the spacecraft, I mean space. So rocket is a spacecraft, but before that rocket is aircraft. So in future, all the aeronautical students and aerospace students, one more thing, there is a big difference between aeronautical and aerospace engineering students. Aeronautical engineering students will not study about space vehicles in detail. They will not study about astrophysics and all, okay? Means inside the atmosphere vehicle is flying, those kind of study is done by aeronautical engineering students. And if you are aerospace engineering student, then you also have to study about rocket propulsion and about the atmosphere, because you are going to design something which is flying, which is going to fly outside of the atmosphere of any planet, okay? So I was discussing aircraft propulsion. So in aircraft propulsion, you can say this as a jet propulsion and you can say this as a rocket propulsion. And I hope you know that why I am classifying like this. So in jet propulsion, whatever things you see flying in the sky, I mean inside the atmosphere, aeroplane, helicopter, like I say, even bullet can be example, some missiles, they are like inside the atmosphere. Yeah, I hope you are aware that there are some missiles, they are launched from the surface or air or water, and they are capable of crossing the atmosphere, going into the space, and then coming somewhere and hitting the target. Okay, so even some missiles are of that level. So in jet propulsion, we especially learn about those engines of the aircraft, those engines are going to be installed in those aircrafts which are going to fly inside the atmosphere. Okay, so typically in jet propulsion we study about engines, okay, and inside the engine whatever components we have, those components also we study in detail. But in rocket propulsion it is totally different, okay? So of course some formulas of and some thermodynamic concepts of jet propulsion are exactly equal in rocket propulsion also. For example, combustion of fuel, okay? So I hope you understand that aircraft propulsion is different. I mean how aircraft propulsion is split into jet propulsion and rocket propulsion, okay? Now next thing, when you are going to study jet propulsion and rocket propulsion in GATE aerospace department, jet propulsion is a different subject and rocket propulsion is a different subject. Now in jet propulsion, if you want to go in jet propulsion, then you should have a very good grip on thermodynamics. Same goes for rocket propulsion. You should be very, very good in thermodynamics. So if you want to understand thermodynamics, it means you should have basic grips in physics. So you don't have to learn lot of physics to understand thermodynamics, and whatever thermodynamics you should know to learn jet propulsion, I am going to teach you here, right? Now, next thing, jet propulsion will be very good subject if you are also having idea of gas dynamics. In gas dynamics, we discuss about compressible flows. Mainly we discuss about compressible flows. I will explain these things. Now, you may have heard that gas dynamics subjects people learn under aerodynamics. But I teach gas dynamics under jet propulsion because I believe student has to be good in gas dynamics, then only student can understand some phenomena of jet propulsion in detail. For example, choking of nozzle. Okay, I will explain you what is nozzle and diffuser and blah blah things slowly in the subject. So I want to classify the engines now. So in jet propulsion, whatever types of engine we are going to study. So a typical engine we say as jet engine. Okay, in this jet engine, you have first engine as turbojet engine. Then you have turbo fan engine. Then once turbojet engine and turbofan engine you will understand, after that remaining engines are based on these concepts, you'll be very comfortable with them. Then you have turboprop engine. Then you have turbo shaft engine. Okay, and after these four engines you have two more engines. So I'm writing here fifth engine. You have ramjet engine. You have scramjet engine. SC, scramjet engine. Scramjet engine. SC means supersonic combustion ramjet engine. It means this is nothing but a ramjet only, but this stands for supersonic combustion. Okay. So in jet propulsion we study all these engines. Now these engines are similar in so many ways and they are different because of their application and little bit modification in the design. Okay. Now in what way they are similar? So I'm changing the page. In what way they are similar? See, in all the engines, I am not considering ramjet and scramjet now, but remaining four engines, they have diffuser. Even in ramjet and scramjet, you have diffuser. Then after diffuser, you have compressor. Even in ramjet and scramjet, you don't have compressor. Then you have combustion chamber, or you can say combustor. Okay. Now this combustion chamber and combustor is present in all engines, even in ramjet and scramjet. Then you have turbine. So compressor and turbine, they are rotating parts in the engine and they are not present in ramjet and scramjet, but they are present in the remaining four what I discussed just now. And then you have fifth one, that is nozzle. Nozzle and diffuser, they are simply a duct. These ducts are present in ramjet also and scramjet also. I will explain one by one. Now what happens in different components of the engines. Okay, now one more thing. By adding some fan and by adding some propellers, we can modify one type of engine into another type of engine. These things I will discuss when I will come to the engine part in detail. So I'm saying every part of the engine is going to do some effect on the air. I am using the word air. So some people will compress the air, some people will heat up the air, and this air will get expand in some components. So it means what? I have to study the behavior of the air. Okay, and you know that especially combustion chamber. In combustion chamber we add some fuel. After adding the fuel, this air becomes a gas. What is difference between air and gas? A common difference I will tell you. Air is diatomic gas. It is mixture of oxygen plus nitrogen. But when you add fuel into this, what kind of fuel? You can simply add any like some fuels made up of carbon and hydrogen. We say methane, propane, butane. These kind of people we consider as hydrocarbons. So hydrocarbons, when you will add with air, then you will be getting sometimes triatomic gas with diatomic gas. So overall, molecules of triatomic gases will be more. So that's why air will not be a pure air. After it will pass through combustion, it will become gases. So see here what is going on. Actually, before study of these people, you should know these kind of chemistry and thermodynamics behind this. Okay, then only you can perform very well in propulsion. So I am starting with thermodynamics. So in thermodynamics, we start with our first topic, and that topic I start as concept of continuum. Okay, and see, whatever I am teaching here, everything is already present in handwritten notes on Google Drive, and you can access them. But no need to access them, because I will encourage you to make your own notes. How will you make notes? Whatever headings I'm writing here, whatever words I'm writing here, those things you will write down on your own notes in your own handwriting. So that will give you more comfort. Yeah, but for any difference and all the books are there, everything is there. You can have that. But you try to solve more numericals. I am teaching here concepts. I will also be giving you here examples, and lot of practice I will be giving from my side, and from your side also. You try to focus more numericals. So concept of continuum. What is the meaning of concept of continuum? See, I'll give you one example. Suppose you have to go from point A to point B. So I'm giving you block here, block here, block here, block here. You jump from this, jump here, and reach to block B. Okay, this is one case, and I'm giving you another case. In another case, from point A to point B, I'm giving you a straight road. So even you can roll your body here and you can reach to point B, but you cannot roll your body here, because if you roll your body here, you will fall down in the gap. Okay, so this is discrete, but this is continuous. First one is discrete, second one is continuous. So what gap you are seeing here, now consider this as a gas. So now consider these people are as molecules. So it means what? These molecules are not attached with each other. It means they have gap. So now to study thermodynamics, we consider that there is no gap. It means what? In case of gases and in case of liquids, or you can say fluid. What is fluid? See guys, when you have matter, so in thermodynamics, matter you can divide only into one is solid and one is fluid. Now fluid you can further divide into liquid, gas, plasma, Einstein, Bose, these things. Okay, so when you say gas, that is also fluid. When you say liquid, that is also fluid. So I was saying, we consider that there is no gap. System is continuous. In real life, it is not continuous, but actually system is continuous, right? For example, best example, suppose this is a shirt. Okay, suppose this is a shirt. So this shirt is made up of cloth, right? So see, try to understand. But if you will zoom, keep zooming, then there will be one situation when threads, you will see only threads, right? It means what? Here you have gap. So this gap you will be able to see when you will zoom enough. If you will not zoom enough, you cannot see the gap, right? It means when you are seeing this with naked eye, you are not seeing the gap. But when you are not using naked eye, when you are using any instrument, for example, any microscope or something, then you are able to see the gap. Okay, so now try to understand. In the GATE aerospace studies, we don't see our gases or our system at molecular level. So how do we see, and technically how will you sound? So you will say view. We have two types of view to see anything. One view is MACRO, macroscopic view, and another way is microscopic view. Okay, in macroscopic view, whatever you see, you don't see at molecular level. But in microscopic view, you see things at molecular level. Okay, in microscopic view, for example, if I am keeping 1 cup of tea here, in this cup I am keeping some tea here, okay? So this tea is in rest because it is kept on table. This tea is in rest. So now I can ask you, this tea is in rest or not? Then you will say, yes sir, tea is in rest because right now it is kept on the table. But at microscopic level, if you see, then tea is nothing but you have molecules of sugar, you have molecules of water, molecules of milk or whatever. If it is lemon tea, you have like some molecules are there present, right? Those molecules are not stationary, they are moving molecules, right? So these molecules are moving. So now you can see at microscopic view, system behaves differently, and at macroscopic view, system behaves differently. Okay, so you have two views. So let's define them one by one, like their very good behavior. So you draw one line like this, and this side you write MACRO, macroscopic view, and this side you write microscopic view, MICRO. Okay, now in this side you write the first point as this is based on overall behavior. So overall behavior of system. But here we don't see overall behavior of the system. We see molecular behavior. What do we see? Molecular behavior. Guys, one more thing. What happens most of the time, some explanation, even we are learning macroscopic view, but some explanations are worth when we give microscopic level explanation. Okay, and see, everyone cannot explain everything at microscopic level. So even I am having limitations because of my knowledge, and everyone is limited because of their knowledge. So if you will expect everyone to explain things at microscopic level, it is not possible, right? Because there is difference between engineering student and a science student. We are actually learning things at microscopic macro, MACRO, macroscopic level. But a science student, especially of this department, they may learn things at microscopic level, because I am not a science student, so I don't have much idea about this. But because I have been aerospace engineering student, so I know, okay, that we don't deal everything at microscopic level. Okay, for example, if I have a rocket, okay, here in this zone combustion is happening, these hot gases are coming out, so I will bother macroscopic properties, MACRO, macroscopic properties, how much velocity is here. So I will not discuss velocity of a single molecule, I will discuss velocity of the jet. So see the difference. But if someone is studying situation at microscopic level, then they may bother about molecular behavior of the system. They will discuss about entropy of every domain, and those things they will discuss. Okay, I hope you understand the gap, what gap we keep between macroscopic view and microscopic view. Now take the second point. So now in the second point, see, if you talk about pressure, if you talk about temperature, if you talk about volume, these properties are based on macroscopic view. But in microscopic view, you cannot, this is point 1, this is point 2, you cannot sense these properties, can't sense. See, why do we feel pressure? Suppose I have a water column and fluid is there. Then this is the height h, and now in this I have mass m. So I may ask you that what is the pressure experienced at the bottom. So that pressure P, you can say hydrostatic pressure I am asking. So you will say rho GH is the hydrostatic pressure. So this G is actually because of earth, so it is not playing good role in my explanation. But what about this H and what about this rho? Okay, rho means density, right? Density. So density of the oil, density of the water. We do not say density of the molecule. Try to understand this. We don't say density of the molecule. Do we discuss density of H2O? No. We say I have a glass of water. What is the density of the water? Then someone says 10,000. I'm sorry, 1,000. Okay, when you say 1,000, then you mention 1,000 kg per meter cube. It means what? In 1 meter cube, 1 kg water will come. We don't say how many molecules will come, correct? So you can see why pressure is present in macroscopic view, because we are seeing overall behavior of the system. Same thing goes for temperature and volume. A single molecule cannot give you volume, right? For example, in this cup, if I'll keep one single molecule of water, it will not give you molecule. So many molecules should come and this should be filled like this. Then we discuss about the volume. I hope you understand that. So now we are going to have second half of day 1. I was explaining the microscopic and macro and microscopic approaches. So in that I was giving you points. So our second point, we were discussing about the properties that at microscopic view you cannot sense the property. And now third point you write down in macroscopic view, MACRO, and here MICRO. So in macroscopic view, you get very less property. For example, if you have a container, in this you have some liquid, so you'll be having pressure, you'll be having volume of in the chamber, you'll be having temperature, you can bother about density, you can bother about enthalpy, these things, like very less. But in case of microscopic view, you can have property related to every single molecule. You can have velocity of every single molecule. Lot of things you can have. You can have momentum transfer between molecules. So in microscopic view, so these things are not useful because we don't look at microscopic level. So these things are not useful for our study. Okay. So now we go for the fourth one. Because you have less number of properties, so you have less number of equations. So less equations. But and simple equations we have. But in case of microscopic, we have so many equations. Why so many equations we have? Because like you said, so many properties. So link all the properties, you need a lot of equations. So much, or you can say so many complicated. So these equations are, like you'll be having complete statistics, like when you'll be having a complete chart of any property. For example, this molecule, you want to navigate its velocity here, then here, then here, then here. It means what? In a space domain of XYZ, you want to navigate the molecule. Then for every coordinate, you'll be having properties. I mean the velocity itself for every coordinate. So much large amount of statistical equations you will be having. So then go for the fifth one. So this kind of thermodynamics, what I'm explaining in left side at macroscopic view, that we say as classical or engineering. So you just mention here classical or engineering thermodynamics. But this one we say statical thermodynamics. So lot of statical data will be there. So these things are studied by pure science students, or maybe in future if you get interest, you can change. You can go into more detail of this science. So this was very basic regarding this. Now I will discuss about system, surrounding and boundaries. So in thermodynamics, we have to discuss about systems. So our system is based on few factors. We define system. For, right now, if I will ask you, then many of you will say that, sir, we have system which is open, which is closed, and which is isolated. But if I will ask, on what basis you are classifying the system? So on what basis you are classifying the system? So the basis, if I will select, then our system will change accordingly. So this open system, closed system, and isolated system is based on one basis. Then I will discuss surrounding, and then I will discuss boundary. So before going into detail of system, let's understand surrounding. So surrounding is nothing but other than system, whatever is there, that is surrounding. This is what the basic understanding we have. But suppose I have a system, this I am saying as system, and someone is studying this system. Now system is affecting nearby people or nearby surrounding. So the local surrounding we consider as surrounding for our thermodynamics. Very far surrounding we don't consider as our surrounding. Immediately after system we have local surrounding which is being affected because of some system things. Some phenomena is happening in the system, that phenomena is affecting the nearby surrounding. So the nearby surrounding is actually your main surrounding, which is known as thermodynamic surrounding. Okay, and what is boundary? Boundary is something which is dividing this system from the surrounding. So boundary itself can be based on few things. So now I'm explaining the boundary. So see, when you discuss boundary, then in the boundary itself, your boundary can be rigid like a wall. Okay, so mostly it is wall when it is rigid boundary. Okay, and there can be condition that boundary is not there but we are showing the boundary. It's like virtual boundary. Boundary is not there but we are considering a boundary. For example, in map of the world we draw lines, but in real life on earth we don't have lines. So we are creating a boundary to say that this is different country and this side we have different country. So with this kind of situation, we understand that okay, even boundary helps us to say that this side system, this side this side surrounding. Okay, so boundary is nothing but it divides system and surrounding. So one is rigid, and if boundary is not rigid, then then it can be movable. Boundary can move also. So if system can be boundary can be rigid and it can be movable boundary also. Okay, now in real life you can have real boundary present. Okay, really that boundary is there, or there can be situation boundary is not there but we are considering the boundary is there. Means suppose that kind of boundary I can explain now. So I will take one example. Suppose this is the pump, so piston cylinder. So see, this piston itself, suppose you want to study this much gas, like what is happening with this much gas. So this gas becomes your system. Now when you will pull up or pull down the piston, then here you have one boundary which is attached to the system. That boundary is saying that inside this you have gas. So this boundary is sliding down with the system. So this boundary became movable boundary. And what is rigid boundary here, or how will you say wall boundary? So you can see this wall, you can see this wall, this wall. Okay, so boundary can be static also, means boundary is not moving, and boundary can be movable also, like boundary is moving. For example, you have a, like suppose this kind of football, now you are filling air inside, then football becomes this. So earlier boundary was like attached to the wall like this, and now your boundary became like this. So without moving, it cannot be like that, right? Why are we defining boundary? Because inside the boundary, whatever is there, that is my gas, and we are going to study that gas. That's why we are defining the boundary, right? So rigid, fine, movable, fine, real boundary or imaginary boundary. Like you can have real boundary, really boundary is present, and imaginary boundary means boundary is not present. I am changing the color. How will you understand that boundary is not present? Suppose you have this atmosphere, or take the example of nozzle. Suppose you have nozzle. Okay, air enters into the nozzle. Now I want to study the behavior of the air in this domain or in this control volume. Okay, so I should not draw this kind of line here. Why? I should draw dotted line here, because in reality there is no boundary present. We are creating virtual boundary. So this is our virtual boundary, this side and this side. I hope it's clear. Okay, wherever you see hole, wherever you see that okay, simply air is there and I am dividing this part as my like interest of study, so you should not draw this kind of dark line, you should draw dotted line, okay, to show the control volume. That is your system. So now I'm going to explain, because boundary over and surrounding over. Now let's understand the details of system. So in case of system, what is system? System is something what you are going to study. what you're going to study, every student can have different study purpose. For example, suppose this is the pipe. In this pipe, flow is there, flow is there, flow is there. I am choosing 3 students and I am saying that student 1 will study this system, and here student 1 will calculate velocity, and in same way student 2 will calculate pressure here, and student 2 will calculate something else like temperature. So all the students are going to study same system but at different locations for different properties. So what is the interest of this student? First student, this student is having interest in this system for a particular cause. So whenever you study something, you have cause, and then you define, okay, only this much is my zone to study for study purpose. So this is how you define, okay, this is my system. So when you define system, you will say that, okay, my system is open or closed. So you can clearly see here, this student, what this student will say, my system is open system, because mass is entering into the system and mass is leaving from my system. Okay, for example, if I have a football, inside football, suppose right now football is at rest. So right now inside I have some gases and someone is kicking the football, then football is going into the air. Then when the football is in the air, that time how these gases are behaving. Okay, so right now your system is closed. Mass is neither entering nor going out. Mass is neither entering nor going out. But energy, for example, heat may come in, may go out. Okay, any type of radiation may come in, may go out. Okay, so you understand that there are certain ways we classify system. So now I am going to classify system. So my first classification about system is based on mass and energy transfer. Mass and energy transfer. Based on this, it is very popular classification. We have open system. What is open system? Open system is something like this. Okay, in this something will enter and something will go out. So it means what? Mass and energy both can enter, both can go out. Anyone, I mean, even if something is not going out, but if something is entering, that is also open. Open means one side should be open. Open means how will you judge one granted thing? Mass. Main thing is mass. If mass can enter, it is open system for sure, because energy is anyway can enter if system is closed system. So now second is closed. What about closed system? Very simple. You have a pipe like this. Now inside this, whatever mass is present, that mass will not change with time, but any kind of energy may enter. What kind of energy may enter? Suppose this is your system. You put one fan here. Now you rotate the fan. So whatever mass is inside, that mass is not going to change, but you are doing some rotation. That rotation is being transferred inside. That is also one form of energy. Okay, you can heat the system, then heat will enter to the system. Okay, or you can also do something. For example, you put one positive plate of charged battery and negative plate, then electric field can set up here. So I'm trying to say that there can be several ways to transfer, to send energy inside the system or to take the energy outside of the system, right? And the third one is a very good system, that is completely isolated. Mass is also not allowed, energy is also not allowed. But in second case, only mass is not allowed, energy is allowed. Clear? But this kind of system is based on mass and energy transfer. Now I will discuss. You can have system which is based on spatial uniformity. For example, I'm changing the page. Taking new whiteboard. So second classification is based on, you have a space, so we say spatial. It's not spatial, it's spatial. Okay, it is regarding space. Uniformity. Uniformity. It means what? System what you are going to study, that is homogeneous or heterogeneous. Okay, homogeneous means, suppose here you can have closed system. First of all, I have to take some system, so I'm taking closed system. Now in closed system, in this zone you have different density material or different temperature you have. In this zone you have different temperature T1, in this zone you have different temperature T2, and someone is studying this temperature. But one system can have like everywhere I have same temperature. Okay, so you can see some kind of uniformity and non-uniformity is there. But what system I am going to explain here, that is spatial uniformity, means it is regarding mass distribution. Okay, so in that your first category is homogeneous. In homogeneous, mass will be present everywhere in same amount. For example, a cup of tea. If you take first sip in your mouth, same taste. If you take last sip in your mouth, same taste. It means what? Mass was all the mass of sugar, mass of water, milk, whatever, is actually completely like uniform everywhere. That's why. So suppose you want a sample, you can have this sample or you can have this sample for any testing purpose. Sample is going to be same, so mass distribution is same. And you can have non-homogeneous. For example, you may have seen in some YouTube videos or reels on Instagram, like nowadays sometimes they show that from this side one water is coming in the ocean, and from this side different water is coming in the ocean, and here in the middle they are being mixed. Now you try to understand, if some student in this field, they want to study the nature of the water, here they will find different water, here they will find different water, here they will find different water density, right? Color also can be different. So even though it is open system, water can come and go, but here you don't have homogeneous system for the study purpose, right? Now I can also explain in aerospace department. In our combustion chamber, from here air will come and from here fuel will come. So now here some mixing process is going on. So when the mixing process is going on, exactly that moment it is heterogeneous, because air density and fuel density will be changing. So you cannot say that it is now, but once the proper combustion is done, then you will be having again a gas, which you can say again a homogeneous mixture, because we design our combustion chamber in such a way that we should get a very good flow, like a complete gas. That's why when I will be teaching you later, I'll be using CPG for gas this side and I'll be using CPA for the air this side. Okay, now based on mode of work and energy transfer, the third system is based on mode of work and energy transfer. So again you have first category in this, that is simple compressible system. You say as simple compressible system. What is this? Here in this system, only one type of work you will supply in the system. Now second one is non-simple compressible system. More than one form of energy will enter into the system. Simple compressible system means only one mode of work transfer is allowed. For example, you have system here. So only one mode of work. For example, I gave the fan example, right? You rotate the fan, only this fan is sending some work inside. That's all. Now you can have non-simple compressible system. In this, suppose you have this. Now here you are sending one work here. You can send one more form of energy. You are sending heat also. You are taking heat also out, Q1 and Q2. So like this. So now I will discuss thermodynamic properties. I'm changing the page. New page. Now I will discuss thermodynamic properties. So here, when I say thermodynamic properties, what are the names should come in your mind? Pressure, temperature, volume, density, enthalpy, entropy. These are thermodynamic very famous properties. Okay, you can also say entropy. Okay, entropy symbol is S. So you can also say heat, you can also say work. Some of these properties are point function or you say state function, and some of them are path function. So remember, when I discuss about properties, I will classify them as point function, that you will also say state function. and path function. Path function. How will you know which property is point function or which property is path function? Don't be confused with extensive and intensive properties. Don't be confused, okay? Point function and path function, these properties we classify in different way. Extensive, intensive, we classify in different way. Don't be confused. So how will you know that some property is point function and someone is path function? Changing the page. I used to give very good example when I teach this. So first understand in some basic lifestyle. Suppose I have some old students here. So suppose one student is Priyanshu, and one student is Banani. Okay. So suppose Priyanshu boy and Banani is girl. So suppose Priyanshu have taken some 1000 rupees borrow money from Banani. Now Priyanshu has to return this money. Okay. So what will happen? Priyanshu will ask Banani on phone call how to come to give your money. Now don't say that, sir, why to go and he can do Google Pay, Phone Pay or something the way you guys are paying my fees. But to explain that they are friends, so they will meet. Okay. So Banani is telling that, okay, come from point A to point B, then go to point C and then point D and then here my place, like this. So he asked, okay, how many kilometers, something. So suppose she said that, okay, some 100 kilometers. So for 100 kilometers, suppose he's having a car. So for 100 kilometers, he will put petrol in the car and he will have some snacks items in the car to eat on the way and some water bottles on the way. Okay. But when he started the journey, she called him and she said, Priyanshu, don't follow that path because of some traffic issues. Don't follow that path. I am telling you a new path. So in that new path, now she's saying, go to some other point L, then go to M, then go to N, P, Q, R, S, T, U, V, W, X, Y, Z, like this here. Now you see, few things will change. Amount of petrol will change. Whatever snacks he is putting in the car on the way, that will change. Time taken will change. Okay, few properties will change and few properties will not change. For example, Priyanshu himself will not change. Priyanshu will not become Himanshu. Okay. Next, the amount of money what he has to return, 1000, that will not change. Yeah, but of course, he can say, man, I have traveled so much, even this 1000 I spent on the way. Okay. So I hope you understand that few properties are depending on path in this example. Now try to understand this example in our thermodynamic way. So heat, that is Q, and work transfer, that is W. Okay. Now when I say work transfer and heat, these two people are path function. Always remember, path function. Why? Because these two people depends on path. What kind of path? In thermodynamics, you have state, process, cycle. So there you will understand path. Which path you are taken to go from one state to another state. Which process you are following. Okay. So heat and work, these two people depends on path. And you can experience these two people only on the skin of the system, on the transient skin of the system. Okay. You can never store heat and work in the system. Okay. Don't be confused with temperature and heat. They are different. Heat has unit joule. Temperature has unit Kelvin or degree Celsius. Right. Heat has unit calorie. Temperature is different. Temperature is not calorie. Okay. So heat and work, these two people. But in upcoming lectures, I will tell you that there is one type of work that is point function. That is not path function. Himanshu or Banani, can you guys recall the name of the work done? Flow work. Very good. So flow work is one type of work which is point function, which is not path function. Okay. For example, how do you calculate flow work? Suppose you have this kind of system. So now in this system, at the inlet, air is entering at pressure P1 and some volume is maintained here V1, and here it is P2 and volume V2. So P2 V2 minus P1 V1. This thing, see, on the way what is happening doesn't matter. Exactly at this state you have P1 V1 criteria, at this state you have P2 V2 criteria. So this work done is based on P2 V2 minus P1 V1. This is your flow work. So when I say work done, this is not flow work, okay, other something else. So work done and heat, they are path function, and I will tell you there is a way to calculate, okay. And other than these two people, everything is point function. There is a way to calculate, mathematical way. I'm changing the page. See here. Suppose you have any thermodynamic property that is P. Now everything, all the issue what we are discussing, that is regarding path. Path is nothing but xy coordinates. So suppose this function P, this property P is the function of xy. Okay, because we are going to understand that how to understand mathematically that any property is path function or point function. Okay, so now this property P, if you want to make any change in this property, then this property will change if x will change and y is constant, or if y is being changed and x is constant, or both are being changed, then this property P will change. So change in this property dP, you can write like this: dou P by dou x into dx. It means what? This much change will come when y is constant and only x is changing, plus dou P by dou y into dy. It means what? This much P will change, y, if y is being changed. But if you will use plus sign, it means what? This much property will change when both x and y, they both are changing. Okay, now you see this derivative dou P by dou x, I will call as m. M is equal to dou P by dou x. And this property dou P by dou y, I will say n, that is equal to dou P by dou y. Right? Now, if you further differentiate this m with respect to y, I mean dou m by dou y. And if you further differentiate this n with respect to x, dou n by dou x, and if they are coming equal to each other, then we say exact differential. It means what? This property is exact differential. In that case, it is going to be a point function. Otherwise, if they are not same, then it is inexact function and it is going to be a path function. I hope you understand. If equal, so trick is E for equal, E for exact differential, so point function. E for equal, E for exact differential, so point function. Remember like this. Okay, so time is almost over, so we'll do one problem and then I will leave the class. And students who have not done those problems in 10 minutes before the second half I gave you, so those problems you guys try after the class, and you go to assignment of that thermodynamic folder in the drive. In assignment, if you find yes, if it is not equal, then it is path function. Yes, you guys can ask, okay, if you have any doubt. Yes, okay. Okay, now I am giving you a problem. Suppose I have any property P. This property I am giving you as e power x plus log y. This property depends on x and y by using this equation. Now you tell me whatever thermodynamic property is this, it is your path function or point function. So if you want, first just you tell me it is point function or not. Just you tell me it is point function or not. Don't check path function, just you tell me it is point function or not. So how will you tell me? You will calculate your m. M is nothing but dou P by dou x. So if you calculate dou P by dou x, what will happen? E power x will be e power x and log y will be 0. Okay, good. Then you calculate n. What is n? Dou P by dou y. So what answer will come? Answer will come as this part you will not differentiate, only log y you will differentiate, 1 by y will come. Now you do one thing. What? this m you have to differentiate with respect to y. It means what? Dou m by dou y. Correct? It means what? If you will differentiate this for y, it will become 0. Now this n you will differentiate with respect to x, means dou n by dou x. So this property will also go to 0. So you got 0, 0 both. It means they both are equal. So it means what? Even though you know the process just now you have learnt, but in hurry you may do mistake. I hope it's clear because they are equal. Is that all right? Everyone understood this part? Understood, right? Okay. Very good. Now see here. You have access for 2023 batch also. Those old recordings you have access for 2024 recordings also. And right now this recording is going to be for 2025 batch. And you have 2022 recording access also. In all the recordings, I have taken different examples to explain this phenomena, this concept, and you have some good questions kept on assignment. You open the assignment, and if you find that whatever topics I have covered today, based on that topic, if you have any question, you solve them. If you don't have, then wait for next class, and after next class you'll be having enough questions to solve in the assignment. So that's all for tonight. Then I will stop the class, and now I will talk about anything else other than class for 5-10 minutes, so that you all can be, I will explain how to get assignment, how to access the assignment. I will explain how to access the assignment. So now that's all, class over. Thank you all of you. Now I will discuss something which is not regarding the class. Okay. So it is actually the doubt point now. Class over. Let's discuss doubts. So everyone can start asking doubts if you have any. And if you don't have doubts, you guys can leave. Because it is night time. So you can go and have your dinner or sleep or ask your doubts now. Ask your doubts.
So you explained that dou p by dou x into dou x is that amount of x changes when y is constant.
Yes.
And similarly, dou p by dou y is this much amount of y changes when x is constant. What they're called together, that point I missed it.
Total change. So
this much change in property
when both are changing.
Both properties are changing. Okay.
Yes. Okay. Next doubt. Okay, then I will switch off recordings. You guys can ask anything else.